like if we go back to chapter 6, I don't know if you remember, but I was like confused by, where was it? On points, it was on the line. Can I move that? Yeah. Where is it? No. Yeah, no. So I asked Jakub what he think about, where is it? Not here. Where is it? I lost it. Yes, it's here. So on the line here, why do we group by here? And also like, yeah. And what he said is basically like, if you have more than one transect, like you will have more than one ID, and then you will, by grouping by more than one transect, you will be able to have like the distance from every transect. So even if here we do not need to group by or aggregate by transect before calculating the distance, this code make it more generalizable if you use more than one line. So it was the answers we had last time. So I guess I can start on reprojecting geographic data. Well, even if I'm a geographer, even if like, I say like, I graduated from a long time ago and my PhD was not on these topics. I'm not an expert on projecting and reprojecting geographic data. So I'll provide at the end some resources that I find useful, and but I will try to present different stuff. So the learning objective today is like playing a lot with geographic and reprojecting geographical data. How do we interact with them, mostly in Terra for raster package, for raster model data, and SF for vector data. What kind of trouble can we run if we are misusing, I don't know if it's correct spelling, the coordinate reference system? What kind of risk should we face? And how should we transform data, and which one to use? I don't know, a lot of time when you download data from the web, usually, I don't know if you are familiar with shapefile, for example, but the shapefile usually came from at minimum 3 files. Like one is the SHP file, what's in the DBF file, one is the SHX file. The SHP usually record where the points are and how to link them. The DBF record the value to, like, let's say like features, and the SHX is usually an index that's linked them together. If you have just that, usually where you are losing another file, that's usually like the PRG file, which contain a proj string. We will see that later. That is useful for every software to know what kind of projection it is, or geographic, or if it uses a geographic data, what kind of geographic data it uses. Obviously, shapefile is an old format. Now, if you use other format like geopackage, the information will be stored another way. But I still think like it make clear with this old format where the projection was. And if you, for example, like change the projection, transforming it, well, like we will see, and did not add the PRG file, there is no way. I mean, there is way, but it was like guessing which projection was used. So this is important to keep in mind. Like both information, like we will discuss that. Nothing new on that. I'm loading the package. That's all the same. So to use coordinate reference system, which I already seen a bit, the upstream library we are using is Proj. That's the same that I think QGIS is using. I'm not sure if ArcGIS is using it, but I think so too. So it's a library in C++, C, and you can find more about it. And it's offer like a lot of lot of tools for manipulating and transforming coordinate reference system. Before I go, I should say, like, when I was a student, the version of Proj was called Proj 4, which was the fourth version. And it stayed the same for nearly 20 years. But currently we're at Proj 9. And I think the 5 new version came up like in the last 10 years. So the development of Proj have increased a lot. And it generates a bit of frustration, I feel, at least in the GIS community, but it was worth it, I think. Sometimes, like when we used to define coordinate reference system, they can be loosely defined, like said, like, oh, this is a lot long coordinate system, which basically mean like we are using latitude and longitude, but we are not telling like what kind of ellipsoid, which is the shape of the Earth, where is the beginning of it, etc., etc. Where should we start our latitude and longitude? What's the origin point? We also can sometimes use what we call the Proj string, which came with the Proj 4 version, which is a string because it was a string of characters. We are using a system of k value. A k Proj was materialized by a plus and the k equal the value. The projection here was a long lat. The ellipsoid was the WGS84. The datum was the same, and there is no definition here. Which worked like fine for like nearly 10 years until 2015, if I'm not saying something around this period. And another way of saying it is like using an authority and the code provided by this authority. I will admit, like a lot of time we say loosely like 4326 or another like that, because or 38, 57, because they are like well defined and we know exactly. But the author are correct. If you want to define it correctly, it should be a string. So in quotes in R, that's defined an authority, which could be like the EPSG, which stands for European Petroleum Survey Geological, I think. And we'll see letters like when I'm clicking on their website. And the code is 4326. You have other authority. I think mainly the one is S3, like the companies that produce ArcGIS, ArcPro, etc., etc. French government mapping is also an authority. And we will see more, like, but this is on top of my head. This is the authorities that I know. Most of the time, I prefer using the PSG authority, especially because sometimes ArcGIS are proprietary. I mean, they are proprietary, but I do not have necessarily access to their definition sometimes. So I prefer like a definition when everyone has access for issue. But they have like, if one stuff like cannot be said about S3 is like the coordinate reference system is fairly good. That so all of them are the same, but yeah, the one we should use is this one. If you go into the console and type STSRS and like the strings, you will get the whole definition here. And you have a bit more, like if you check carefully, and we will go back later. Let's go into R. Let's do it. So I have SF loaded here. So I can just go STSRS, but you see, like if I go just 4326, it will probably work, but it's not recommended. I mean, it's work here, let's say in an exploratory workflow, but if you are coding stuff that should be reproducible and repeatable, it's better to do like the full version of it, which I will do right away. So let's do it. And see, even if we are working with a string here, and the other side numeric value, it's work the same. So we have like the user inputs. This is basically, it's return URL list, which contain the user input and the well-known text. We'll see a bit later. The user input is what I have written. And if I check, even when I write it 4326 here, SF was smart enough to identify it. Okay, let's go like to the, so we can like spend a bit of time investigating this object. If you want to be like, you have it nicely presented, but if you just ask for the, so it's, let's say Bob, just to store it into an object. Let's still be lazy and ask for Bob, the same. If we ask for Bob and we ask for inputs, we get that. We'll see a bit more later, but what is more interesting, and if we ask for WKT, which stands for well-known text, which is like the new way of defining the coordinate reference system. You know, it contains everything. The ensemble, which I'm not clear what it is, the ellipsoid, the accuracy of the ellipsoid and the ensemble, the units, the where the original, the premium, it's where we should start, the angle units and this definition, the axis, everything is defined, and it's totally like non-ambiguous. And if you want to transform, you have everything. You also have like the bounding box, the scope of this projection, etc., etc. And the ID. This is basically what is used to get it. But if I just use for the element of the list, I got like this, a string with like the line break here. And what SF is basically doing is like, I'm gonna pipe into like another R function, which is cat, and it's just like we'll read it as if a cat, like the Linux function will used, and it will like materialize correctly the line break, which is not in the string. Anyway, so if we go also like to the PSG website, if we go for 4326, but I can go like, I will just like be lucky because this is like one ID usually correspond to one. I have like a small definition where like what the place is covered by it. You see like the origin is here. And then here, this is the interesting parts. You have like all the definition possible. And if you have the classical for Projecting 1, the S3 version of it, which you see it's not the well-known text, which the well-known text 2 and the well-known text 1 are both standard and ISO norm. That S3, for whatever reason, I don't know, do not follow. Currently, we are using this one, the WKT2. But be careful, I have seen like not far than last week, dataset still provided as WKT2, WKT, no. So this is small differences between two of them. And sometimes if you, even if someone tell you like, oh, this is WGS 84, and if it's 40, and still like this, both of them are 4326. But the standard is different and it can be problematic. Then you will have to change it manually or convert it. But you are also like the version like from JSON and all of the other tools like GeoServer, PostGIS, which is like which will reference also like which follow the WKT norm, I think. All of it is contained here. It's super useful to check it. I highly recommend it. Also, if you go, for example, let's go to the French one, 24. This is, you have also like the various transformation available here and all of this information. So yeah, let's go back to the presentation. I think I can click, so I have to go back. Okay, any question about that? Yeah, like I said, like we are currently using WKT2 since 2018, if I'm correct. But I still regulate WKT1 and Proj for string. And sometimes I'm lazy enough to use partial thing. There are also like this ID identifier. It's called a spatial reference identifier, which stands for SRID, which you can also see in the literatures. Okay, so here we are going to see how we can carry and setting CRS. Here setting is the computer science sense. Like I don't know if you know what a setter function is. A setter function is the function that just changes some state into an object, but does not change other stuff relating to it. So this is the perfect example, I feel. For vector, as we have seen, if we want to carry, we can use sf_st_crs function. We have already seen like the $sign and the name of a list help you carry this list. And the same from like, so instead of what I have done here, like, you know, like I have attributed to Bob, I have created an object. I mean, this is also an object, see, and I can obviously use the same trick here. And yeah, the trick that you should use cat if you want it to be like correctly presented. I use a lot in my code the set crs, which is just a convenient function. What it does is so you can like just check it like this is I have just printed the result of it. If you go back into what is it? If you just sf st without the bracket, you will see like how the function is written. So it's a function that takes x and a value, and that will just use stcrs the x equal the value and return x. So it just why I like it. It's just like it's more. Sometimes I feel like, and I do that a lot. Like I just stcrs equal something, return something. I feel this is the code that someone read it is a bit easier. So I like this using it sometimes for code readability, I feel. But if you are using a rasters, this is the CRS function and exactly the same logic. Like I said, setting does not alter the coordinate value or geometries. It's just change the parts of the object that knows what kind of the coordinate reference system is. It does not perform any kind of transformation. So you can carry and setting was like that. This is you are also another way when you are, for example, creating an object from st as sf or importing a rasters, you can directly set the CRS into it. So it's sometimes like you can gain few lines while doing it. And for readability, I do not think it changed too much. Okay, the question about that. Yeah, today we'll not see too much code. We'll mostly like discuss projection. The coding part, as long as you understand this projected and geographic. So I maybe I should repeat that. Geographic is usually defined by a coordinate into the Earth, and the projected is like a planned version of it. You project the Earth into some 2D stuff, while a geographic usually is a bunch of angle, so you can locate the point in an ellipsoid. But we already seen that, just repetition. So we'll use a quick example. So SF use GOS on upstream, which is a C library that is used for doing a bunch of mathematical Euclidean operation and dealing with some topology too. If it's projected, so if you are in GEOS, which was the port of a Java library which called Java Topological GTS. I do not know why the S stands. Java Topological Suite. I don't know. That was like developed, and then you have like the open source, which was Geos, which was developed later. So SF use Geos, like also I think QGIS and a lot of other tools. And if we are using geographical CRS, it uses S2, which is the library developed by Google. Here we have an example. We see we are setting up a small SF object, London, and if we ask if it's long lat, it's not long lat. Even if we have named the code, I mean, it doesn't know because the CRS was not added. If you just set CRS and now ask if it's long lat, so ST is long lat is a convenient function to check if it's a geographic CRS, and then it provides you true. Then if we buffer a bit, so ST buffer, like we provide a buffer. So London is just a point right now. If we want to buffer of a distance of 1 degree, which it's less than 100 kilometers, something like 80, 70s. I do not know. We could calculate it. It will return something that it will try to do like 1 degree plus and 1 degree minus. But 1 degree plus and 1 degree minus is not the same around the globe because the shape of the Earth. So you have a deformation. We will materialize that later. Then we can use a distance, which is like it's totally incorrect. You will think like it's. We can also use S2 if S2 is implied. So we can check like usually when you when you ask like ST, what's I never remember the function to check if it's S2 is installed or not. Is on or not? Yeah, it's this one. So let's say if I say nothing, yes, obviously no namespace. So here by default it said it's true, and I can change it to false. Is logical, is not true. Error in SF. That's weird. Oh yeah. Okay, so now I do not use the S2, and if I want to put it back, it's probably work. Let's try. Ah, no. So it won't true. Okay. So S2 work by cell. So I have put very large numbers of the number of cells. So it's gonna take like, this is 100 kilometers, and so it's in meters. I should have like write that differently so it's more readable. And you can play more cell you add, more you will divide the globe in small square, more your result will be less pixelated, but more time it will take to calculate it. We can do that later. Here I converted to a projected system. And if we want to represent it, I just to test that and see how deformed using just geos with projected not geometric geographic coordinate reference do like an error. So this is just it's fairly ugly, but it was quick. So so I just like used the world data set to extract United Kingdoms. London is around here. I plot it. Then I plot on the behind the S2 buffers, and on top of it, on the like avoid one is the version if I'm not like I'm just doing a random buffer without taking into account the geometric. So you see the deformation. It's a bit taller in the latitude, and it's incorrect in the longitude also. So we can like just play a bit if you want. Like if we probably have time, let's go back and just lower the number of cells. Let's do like, let's see that. Change this object, replot it. See, you have a way more pixelated results. So this is because, yeah, there's no free lunch. Any question about that? And if obviously if you transform it and put it, you get the correct shape. I have not put them together because obviously the coordinate system, this is why I transform it directly here so we can plot them together. Question about that? So this is fairly, I will recommend you, like, in my experience, it's good to be cautious. Like lot of times I disable S2 and because I prefer having an error message, and SF is pretty, like, I think it's doing a good job preventing the user doing bad stuff. But yeah, you need to be aware of what kind of error you can introduce using a projection. And typically running geos on degrees, it works. Like if you are in equators or a place where like the deformation is very minimal, will be fine. But I will, or like if you work like in, let's say, like a neighborhood, the deformation will be like, will not matter. So you will still have like something that's not good. But anyway, the good way is like, and I highly recommend to, if you are working, try to project it, except if you are working on, you know, measuring some distances and stuff like that. Well, maybe a projected is not the good one. Okay, when should we project or not project? Well, there is an easy one. Like, I do not think there is generic answers. My mind is like growing without S2. I learned that I always need to project, because if I wanted to do any kind of calculation, I needed to select the correct represented system for the area and then reproject, which I still follow, but it's true now it's less necessary. But if you want, for example, to use leaflet, you need to be in geographic, because leaflet is by default in EPSG 4326. And if you try to feed leaflet another coordinate system, it will not go well. And also, if you want to compare different kind of objects, if you are not, like, for example, in the same coordinate reference system, they will totally like be plotted not in the same place. This is why, like, previously I had, like, if I wanted just to, like, here put together like my objects that were presented London on a projected, this was done here. London projected. See, we it was reprojects here. I mean, it was not reproject. It was like totally created with the correct value, then assigned the coordinate reference system, then buffered. I mean, it was assigned was the object, SF object was created. It was not a SF object. It wasn't. No, it was an FSF object. My bad. It will, if I wanted to print everything on a single map, here I have degrees on this point, and here I have, like, I don't know, fairly large numbers of meters. So it's not, you need to, if you want to even plot them in the same map, you need them to be like in the same coordinate reference system. And if you want to do some calculation, it will be bad if you do not put them together. I think SF will issue you a warning. I'm not sure if it will try to stop you, but yeah. Okay, which coordinate reference system should we use? This is also like no good answers. And because like you should use the right one for every task. So when I saying that to coworkers, they tend to default like, who cares? I'm just gonna use 4326 because at the end I want to plot that on leaflets. Well, yes, but if you want to calculate error and stuff like that, you will definitely have deformation in some places if you are using. Even in America will look weird. Okay, what I'm saying and what the author says, like you should check what the public mapping agency, the national one, is used, and then use the one that they used. In France, like this is the 2154, and if you are working in France metropolitan, not like obviously you have a different one if you want to work like in Guyana and the island in Pacific, you should use another one. But yeah, you should, and they also recommend the one you should use. So when I'm working in a new country, I always try to find the mapping agency, national one, and see what they offers. But you have other way to know. Universal Transverse Mercator is also like nice to use, especially for areas that have less than 6 degrees, because this is defined by 6 degrees. And you will have farther you go, like of the 6 degrees, more distorted it will be because it's a conical projection. But like this tool, I didn't know about it, and it's good, so we can explore it. Let's say like I have no idea about this place in Algeria, so I want not sticky. I want to click the map to set the location. Here, I want a projected one. I have nothing loading. Oh, so this is my option. Oh, I have trouble with electricity here. I'm back. I'm not back. Yeah. Well, that's fine, I guess. Give me a minute. We had snow today in Ohio. I don't know. Let's snow. And if you pass to it, you will see like what you have. And I guess if I want to do some mapping in these places, I do not have. Oh, here it's maybe correct. So this is UTM. This one's probably the one that's. This one's awful. This one too. I guess the deformation, like it's centered on. So if I have to pick one, I guess I will pick this one. This one. And then I have it links to our favorite website. It's a bit slow. With all the information. So we go back, and you can like, yeah, I selected projected, but you can, and see here, this is the authority. So EPSG S3. I do not know what this one is. This is the French National Agency. This is the Open Geospatial Consortium. And NKG, I have no idea what it is. National something. So this is super useful website. So thanks, Javier, for having built it. So yeah, if you don't know, let's go back to America. Here, I want geographic 2Ds. And this is probably like, this one is kind of a bit too big, but I guess at least it includes Alaska. Can I have just one like, oh, this one is funny. It's for Canada, I guess. Okay. I don't know which one I will use. None of the world one, I guess. Well, I guess this one is maybe the one that people used. I don't know. Projected, what do I have? So I have this one that I like a lot. You know, they are fairly more precise. They are like less the deformation they will have. I think like this one probably I will use, like some UTM2. This is like the all this is the default one like people use. I have seen it a lot. This anyway. It's not very easy with my screen. So this is a fairly good website to help you decide which one you use. And more obviously, just limited to your area, this coordinate reference system is, better the result will be. Now you can pick, you have like, well, the Earth is round, everything, like I say, like if you want, it's not exactly round, but like it's a 3D. And everything, if you want to make it flat, except like for flat earthers, which I guess like they do not have the same problem, because obviously their system is easier. I don't think it's right, but at least it's easier. Yeah, you need to pick like a choice of where to project it, and the choice I divided by what we call conformal, which is a projection that will try to preserve angle, and preserving angle wherever you go make the shape look like the same, even if the area will be smaller or bigger. And then on the opposite side, we have the equal area choice, where you try to keep the area the same. And that's very important when you want to calculate the density, because if you use like a conformal projection and you use it like in, let's say, like for example, the far from the centers of the projection, you will have differences, and the differences will just be because like the projection you are doing does not maintain the surfaces. Then you have the equidistant. I have never used it too much, but it's super useful for people who are calculating distances. So mostly traveling stuff like airplane and stuff like that. And usually like what people does is doing a mix of everything. The goal is obviously to minimize every distortion possible. So the author recommend some of them. So the lumbar azimuthal equal area, which is like an equal area version of it. By the way, if you go like, oh, I found this link. If we go to Wikipedia, there are all of them, and I very like the Tissot indicatrix. So the Tissot indicatrix, so let's say like I'm using a lumbar azimuthal equal area, and the center of it is around the pole. You see like what's the deformation. So here, like the deformation, even like the third circle start to be like totally a mess. The third one, even the second one, you see like it's spread a bit. So, but yeah, the lumbar azimuthal can be like pointed like you have another lumbar azimuthal, but like the center is in here, I guess, the null island. And yes, so you can pick, so this is like an option. You have also like the azimuthal equidistance, etc. The lumbar conformal conic, which is the one the French use for the 2154, which is like, and you see like it's fairly bad. So it's use a conic like cone to project on the Earth. So it's fairly bad here. It's fairly bad here, but it's fairly good here. And oh, I missed that. And finally, the oldest one, which is a stereographic, which is still used for the pole. And you can argue that it can still be used everywhere, but sometimes people call it fish eye. Because if you do photography, like this is the same representation. So you are correct around here, farther you go, and yeah, farther you go from the points, like worse you go. And but for the pole, it's the one like I have seen people used. Question about that? You will most likely never implement them. You will most likely always use the correct one. And if you want to understand what the code means, you need to understand this concept. But yeah. So this is straightforward. I mean, not straightforward, but yeah. So now we have seen like what is what kind of projection a coordinate reference system has. What happens if we want to reproject vectors? So I insist, like while you are projecting something, you are transforming the coordinate points, like the vertices of every point. And usually on the same times, you are setting it. Like you are not like just modifying the point, you are also references what you have used. So usually like when you are like this ST transform, what it does is probably like we should check the function at the end of it. It's gonna probably set the coordinate reference system of the SF object to the correct coordinate reference system. So the next people, who, even yourself or the next line, will be able to use. Yeah, so it has a special class. If I use a type of, I will get like it's a list. We already know that the list object have an input and a well-known text. If I ask, it have a bunch of convenience also, like, so this is SF, like if you ask for the name, you get it. You can also get back the prosh for string if it's needed. Some tools still using it, so sometimes you need it. Or you just want the PSG. So it's basically like, I just like, yeah, I can go, I guess, should be. So CRS, what was it? I have done it here, it's maybe better. Correct that while I'm here. Why this one is, oh, this one was not good. Okay, so we create an object that's and this is a geographic projection. We can SF also like will display, see, you have also like in the header of SF, you have like, it will describe a bit about it. So if I ask this object I created, I can change it, like I could also like change it. If I change it for, oops, sorry, for this Prosh version, or I could just type that, I guess. If I ask for the class, well, it's still the same because the name is still the same. Here, now we have the British National Grid. Well, before I had like, the Prosh for string is way different. So it contains like, the projection is T mark. I have no idea what it is. The latitude is by the 49, the longitude is by -2. So it's probably like on the southwest of England, I guess, of maybe farther because they probably like take into account Ireland. I don't know. The modification is kind of big, and the ellipsoid is airy. I don't know it, and the unit is in meters. So they are also readable. That's it. So nothing really like important, and this is just convenient, but it's super useful to be able to do that while programming sometimes. Well, vectors, like it's just a bunch of points linked together. Raster is another beast because like it just usually record one point with the coordinate reference system, and it derive everything, divide everything, the space into cell. And if you want to reproject the rasters, you will need to modify that. And if you need to modify the shape, say the resolution of the raster, you will probably not modify the extent, but the resolution, the number of cell, number of row times the number of column. You will need to resample every value of every cell, which can very become messy. I should also say, like in this book, we focus on the one kind of raster, which is follow as a rectangle or square cell, but it exists other kind of rasters, the curvy line one. I will not go, I have never used them in my life, so I will not go too much, but they exist. So Terra proposed a function that's called project. That's do both operation. So well, this is just what we have seen. The same, we can do CRS with these rasters and cat to present it more like friendly. So this is rasters. It has been reprojected. So see like this object, which is like LAN covers, is in NAID 84 UTM zone 12. And so it's a metric system projected, yes. And if you use like project to a PSG 4326, it's this rasters is categorical value. So when you want to resample, as usual, when you want to resample categorical data, you should use the nearest neighbors methods, because it does not make sense to calculate value. I mean, to do like, but you have all the time more option if you have value to resample it. But I do not know, like, I don't know if some of you know other methods that the near neighbor method to resample categorical data probably exists, but not that I know or I use. If you are using quantitative data, you have Lankos break, you have bilinears, and you can check them. Like if you check, for example, the project function, like we can do it here. Oops, where I am. Projects. Is it the derivatives? Be sure to search in the correct places. See the method, they have like by default, you have bilinear, cubic, and cubic spline, which is way more power. I mean, yeah, it costs way more power, and I'm not sure it's always right. But anyway, so this is like this is the three you have. So I guess you kind of trapped. I don't know if the other method of resampling exists in other package. I'm not too much a raster guy. Probably some, yes. And that's it. So if you reproject it with near and you check no the object reprojected, well, so this one was in long-lat PSG 4326, and the old version was the correct. And if you check the dimension of it, which contain the number of row and number of core, see we have a small differences. And I do not show it here, but also the resampling create a new category for non-missing value. So it's also can change a bit. The resampling can also change a bit the value you get, which is complicated. Okay, it was long. My too long doesn't read. Well, I'm not doing that every time, but when I'm trying, I have do not present how you can modify well-known text on the fly, but you can, because this is just a list, so you can write it and convert it and pass it. I will advise again, because when you want to transform it against, well, what you have done will not be known by Proj, so Proj will not be able to convert it. So anyway, whenever I'm doing it, something, and I think I need something complicated. For example, at once I worked at the world level, but on surfaces. So I wanted to be as closed as possible as what the surface are. I used Molwade, which is I think the author also recommend, and you have another one that's fairly useful. Yeah, usually I'm checking references and doing bibliography. Other possible option is always use the recommended coordinate reference system by the mapping institution. They are professional geodesist people that know what they do. And to be fair, if you work on small area, it does not matter too much, because the deformation appears on the borders of your projected plane. Like on the center of the projected plane, you're supposed to be good. And that's it. Question, remark. Oh, chat,
Right.
lot of stuff in the chat.
Yep, good stuff.
Oh yeah, Molway is super useful. What is the motivation? I think the motivation is like to be more, to have like a better representation of the surfaces. But I could be wrong. Don't quote me on that. Oh, yeah, I put references that I like. Sorry, I stopped sharing. I need to push that. Where is it? Here. Share, and we can go through them. Share. So this one was provided like on the Geocomputation channel by Michael Sommer. Is an Australian guy working in he specialized in raster stuff and in Antarctic. So you know a lot about coordinate reference system, and this is truly a good. Yeah, it's good. It explains like where and give also good example that I should have gone through, like when should we use like a conformal, what map use conformal representation, topographic map, cadastral map, military map. Well, you want to do not mess your angle and be correct, and maps that share the same area. Every time you want to calculate the densities, you want that. And see, like this is, I think this is Molway, for example. Oh no, it's Eckert-Ford, which is close. They are both like very close. See, like equidistance and example when you do not use like the different kind of projection you can use, like the conical, etc., etc. What kind of object you want to represent? Obviously, if you want to represent a long object, you should use one particular kind of stuff. Like I thinking like, I don't know, is it, yeah, Chile, for example, is a good example. And obviously like Turkey, you will probably use another kind of representation. So yeah, super useful, and go a bit more deeper. For everyday stuff and someone that I don't know, I hate coordinate system. The title said everything, because it explains a lot of basic stuff and give you like quick knowledge why this happened, for example, and how to detect one kind of projection and one another's. And it's also explain what's a ellipsoid, what's a geoid, etc., etc. And yeah, it's super quick and very effective, but it's limited. Like you will not cover everything. And finally, I like this one, but it's more like I think it's a professor in a liberal college in the US. That's he produced fairly well content. There's not too much. So he explained like he go into more like this TISO indicatrix. Like, so this is like, if I use one kind of projection, where's my deformation and how can I measure it? So it will talk to the math teacher, I guess. And you have like, and he explained like how you can generate that. It provide a function, a bunch of projection, and then like you can see where deformation are for every projection. So this is fairly interesting, fairly well documented, like, and it go really well with every projection and go well into it, and how like it deform the representation. But as far as I say, for most of the time, if you work on small, I will push this to the upstream, so it's shareable. Oh, dang, I'm lost. Every time I want to stop sharing it, it's trash. Anyway, I hope you hear me. I will reconnect quickly.
Yep, you're good.
Oh, you hear me. Anyway, that's good. So yes. Yeah, wait, maybe it's Zoom will manage something. So I will push this so you have these references. And yeah, do we have questions? Or are we good? I will force Kit and log.
I don't have a question, just a general comment, I guess. I've probably been pretty spoiled in my working career, having lived and worked my whole life on Long Island, which is just one little sliver of that whole big map out there.
I'm
And
back. Sorry.
Just being 112 miles long and 30 miles wide, like you said, it doesn't matter much over
Yeah.
very small distances. And we have a local, like you said, the local mapping authority. We have the New York State Plane Coordinate System, which is a NAD 83, and it's locally referenced to somewhere in New York State, and it covers all land area. So that's really the only conversions I've had to do are from like the NAD 83 to the web the
Yeah.
web Mercator one for use in like ArcGIS Online and their standards. So it is it does get very complicated when you look at all the large areas and dealing with the world maps and not distorting them. But I guess I've always fallen in that little bit of over small distances. Doesn't matter too much, and it's a rounding error basically.
Yeah. For like, let's say like if you pick one US state, a big state, you could be on 2 UTM zone, then it could be a bit tricky. But even that, I'm pretty sure like the USGC provide you something that's fit the bill. But yeah, no, it's complicated. Also, like when you go, like if you are mapping in some places where people did not provide good standard, you probably like need to adapt yourself. But yeah, no, it's matters like, yeah, the most error I have seen is people doing buffer calculating distance with geographic coordinate reference system and not knowing like this will totally change because yeah, the angle does not mean the same projection on the Earth wherever you are. So yeah, like the example in London, like 1 degrees for 100 kilometers is correct in the equators, and it's not anymore. Like London sadly is not the equators. I don't know if it's sadly or not for the British people, but yeah, that's it. No, it's important to avoid mistake. That's it. That's my point of view.
I think the book example was somewhere between 77 kilometers versus the 111 at the London location,
which is big. Like
right.
if you make like 23 kilometers error on one side, like it start to notice, you start noticing. But yeah. So yeah, and I think now also with Proj 9, we kind of stabilize the standard, and we will not see new standards soon. Like, like this development, because what's happened is like, yes, a continent are moving, Australia is moving. So for example, the ellipsoid is fixed on time. And if you want, like, for example, when you take a coordinate reference with a GPS, it's by default usually WGS 84, which is like the port, like if we are clear, PSG 4326. And this was used when like I do not remember when it was like fixed, but no, Australia have moved, and the point you have taken at that time is not correct anymore. So I think geodetic people want to move for when you get a point, you also have the date, so you can like adjust it. But for most, we are, for some places in the globe, like Australia is moving fast. I was surprised. Like in 10 years, it definitely can matter. But I don't think in the US it's matter too much. I have not checked the numbers, but yeah. So does WKT 2, I think it's stable. I think like we have at least 5 years of it without learning a new standard, which is good. I don't know, like some people were saying like, you know, with automatic car, we need to be super precision. And obviously, I think there was a trouble before like this super precision, but well, that's it. I
Thank
speak a
you.
lot.
Yes, thank you.
Yeah, thank you. It's all
Thank you,
good.
bye.
We'll see you in a week.
See you in a week. And yes, see you, Jim. Good luck.
Yep. Bye-bye.
Bye.
That's all. Yep. Thank you. Good discussion.
bye.
Have a good night all.